Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to design interdigital bandpass filter. So this is the general configuration of interdigital bandpass filter. The configuration as shown consists of an array of n TEM mode or quasi-TEM mode transmission line resonators, each of which has an electrical length of 90 degrees at the midband frequency and is short-circuited at one end, and this is short-circuited one end of the line and open-circuited at the other end of the alternative orientation. In this general representation, so one end is short-circuited line and another end is open-circuited line. In general, the physical dimensions of the line elements or the resonators can be different as indicated by the lengths. That lengths are L1, L2, L3 and so on, Ln, and the widths are W1, W2, W3 and so on, Wn. The coupling is achieved by vary the field springing between the adjacent resonators separated by the spacing S, and this is the spacing between these two elements. So that spacing elements are S12, S23 like that. So design example with asymmetric coupled lines. So this interdigital bandpass filter can be explained into two cases. One is asymmetric coupled lines and second one is symmetric coupled line. In this video, I am going to design asymmetric coupled interdigital bandpass filter. So now here in this design, I am considering the designated operating frequencies 2 GHz and type of the material is Roses RT or Duride 6006 and its dielectric constant is 6.15 and thickness of the substrate is 1.27 mm. So using these parameters, using microstrip online calculator, calculate the 50 ohm transmission line width is 1.85 mm. And this is the layout structure of the 5-pole microstrip interdigital bandpass filter using asymmetrical coupled lines. So this is the response curve. So in this layout, this is 50 ohm transmission line and this is 50 ohm transmission line. So these are the 5-poles 5-pole microstrip interdigital bandpass filter, and this is the first pole, second pole, third pole, fourth pole, fifth pole. Now open HFSS software. So first draw the substrate, select the box, draw the box anywhere in the plane, give the rename of this box 1, this is substrate, and select the type of the material is Roses RT Duride 606 and its dielectric constant is 6.15. Now change the dimensions of the substrate. The length and width of the substrate is 30 mm, the X size is 20 mm and Y size is 30 mm and Z size is 1.27. The height of the substrate is 1.27 mm minus 1.27. to 7. And X portion is half of the X size value before indicating negative sign, minus 10 mm, and Y portion is half of the Y size value before indicating negative sign, minus 15 mm. Z portion is 0 mm. Click OK button, select fit all. So this is substrate. So below the substrate we can design ground plane. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet. This is the ground plane. So the dimensions of the ground plane is same as that of the dimensions of the substrate. X size is 20 mm, Y size is 30 mm, portion is minus 10 mm, minus 15 mm, and Z portion is, the height of the substrate is 1.27, so the Z portion is here minus 1.27 mm, and this is ground plane. On the top of the ground plane is substrate. So on the top of the substrate we can design interdigital band pass filter. So first draw the 50 ohm transmission line. Select the rectangular sheet. Draw the rectangular sheet anywhere in the plane. So now here, so the width W1, W5 is 2.2 mm, W2, W4 is 1.1 mm, and width W3 is 2.6 mm, and the spacing is, so S1 to S45 spacing is 0.2 mm, S23, S34 spacing is 0.3 mm. So now here in this layout, so this is 20 mm, this is W1, W5, W2, W4, W3, and this is the spacing. So now here this 50 ohm transmission line, width is 1.85 mm and length is 4.9 mm. And give the rename of this rectangular sheet. This is 50 ohm transmission line. Change the dimensions of the 50 ohm transmission line. Axis is the Z axis. So now here the length of the 50 ohm transmission line is 4.9. So minus 4.9, and Y size. Y size means width of the 50 ohm transmission line. The width of the 50 ohm transmission line is 1.85 mm. And position, X position is 10 mm and Y position is half of the Y size value before indicating negative sign, minus 1.85 by 2, and Z position is 0. Click OK button. So this is 50 ohm transmission line. Draw the 50 ohm transmission line and another 50 ohm transmission line this end of the substrate. So now select this 50 ohm transmission line. Press Ctrl C, Ctrl V. Change the dimensions of the this pasted element of the 50 ohm transmission line. And this is minus 10 mm and X size is plus 4.9. And this is another 50 ohm transmission line. Next draw the line. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. Change the dimensions of this rectangular sheet. So this is first rectangular sheet. So this width is W1. This width is W1 and length L1 is 20.14 mm. So W1 is 2.2 mm and length L1 is 20.14 mm. And X size is 2.2 mm and Y size length is 20.14 mm. So now here this 50 ohm transmission line X portion is 10 mm, and this 50 ohm transmission line length is 4.9, and 50 ohm transmission line X portion is 10 mm minus the length of the 50 ohm transmission line is 4.9, five 5.1 minus this width is 2.2. So the exposition of the this W1 exposition is 2.9 mm. This exposition is 2.9 mm, and Y position is half of the Y size value before indicating negative sign, minus 20.14 by 2, and Z position is 0 mm. Click OK button. And select this rectangular sheet. Press Ctrl C, Ctrl V, change the dimensions of this pasted element of the rectangular sheet, and this X position is minus 2.9, and X size is minus 2.2. And this gap value is S12 is 0.2 and W2, and next line is W2. W2 is 1.1 and its length is L2 is 17.85 mm. Next select the rectangular sheet, draw the rectangular sheet anywhere in the plane. So change the dimensions of this rectangular sheet. So this rectangular sheet width is 1.1 minus 1.1 and length is 17.85. So minus 17.85, and position. So this rectangular sheet X position is 2.9, 2.9 minus, and gap value is 0.2. S12 gap value is 0.2 minus 0.2. So 2.7. So this rectangular sheet X position is 2.7 mm, and Y position is 10.07 mm. Z position is 0. Click OK button. Select this rectangular sheet 3. Press Ctrl C, Ctrl V. So change the dimensions of this rectangular 4. This exposition is minus 2.7 and X size is plus 1.1. Click OK button. And this rectangular sheet W2 and W4. Next draw the rectangular sheet W3. W3. So W3 width is 2.6 mm and length L3 is 17.72 mm and the spacing between W2 and W3 is 0.3 mm. Now select the rectangular sheet, draw the rectangular sheet anywhere in the plane. Change the dimensions of this rectangular sheet. So this rectangular sheet width is 2.6 minus 2.6 and length is 17.72 minus 17.72 and exposition. And this rectangular sheet exposition is 2.7. Now here the gap is 0.3. This rectangular sheet exposition is 2.7 minus, and this rectangular sheet width is 1.1 minus, and gap value is 0.3 minus 0.3. So this rectangular sheet W3 rectangular sheet with exposition is 1.3 mm. And Y position is 10.07 mm. Click OK button. And after that select via whole ground. So now here the via whole ground, the radius I am considering 0.5 mm. Select the cylinder, draw the cylinder anywhere in the plane. So change the dimensions of this cylinder. So give the rename of this one via whole ground. Change the type of the material. Now we are selecting the material is copper material. Change the dimensions of this via whole ground, and radius is I am considering 0.5 mm, and the height of the substrate is 1.27. So this height is minus 1.27 mm, and position x position is 4 mm and y position is 9 mm and z position is 0 mm. Press OK button. And select this via whole ground. Press Ctrl C, Ctrl V. So change the dimensions of the pasted element of the via whole ground. And now here the exposition is minus 4 mm. Click OK button. So this is via whole ground. This is via whole ground. And this rectangular sheet and this rectangular sheet. Next draw the via whole ground of this rectangular sheet and this rectangular sheet. Select the cylinder, draw the cylinder anywhere in the plane. Give the rename of this cylinder via whole ground 2, and type of the material is copper. and change the dimensions of this via whole ground, and the radius is 0.5 and height is minus 1.27 mm, and X portion is 2.15 mm, and Y portion is minus 7 mm, Z portion is 0 mm. Click OK button. And select this via whole ground to press Ctrl C, Ctrl V, change the dimensions of pasted via whole ground, and now where the X portion is minus 2.15 mm. Next, draw the via whole ground of this middle one. Select the cylinder, draw the cylinder anywhere in the plane. Give the rename of the cylinder one. This is via whole ground 4, and the type of the material is copper. Change the dimensions of this via whole ground. The radius is 0.5 and height is minus 1.27 mm, and position 0 mm, 9 mm, 0 mm. Click OK button. And after that, select (50 ohm transmission line and this rectangular sheet 1. Click Unite button. These two are unique. And select another end of the 50 ohm transmission line and rectangular sheet 2. Click Unite button. These two are unique. Now assign port 1 and port 2 and rotate the structure. And this is Y axis and Z axis. Change the plane, YZ plane. Select the rectangular sheet. Draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet. This is port 1. So change the dimensions of this rectangular sheet, and this Y size and width of the 50 ohm transmission line, and this is 1.85 mm, and height of the substrate is 1.27, so Z size is minus 1.27 mm, and X portion is 0 mm, sorry, X portion is 10 mm, and Y portion is half of the Y size value before indicating negative sign, minus 1.85 by 2. Z portion is 0 mm. Select this port P1, press Ctrl C, Ctrl V, change the dimensions. This X portion is minus 10 mm, click OK button. And this is another end of the port. Now assign lumped port excitation of port 1 and port 2. Select this port 1, right click on the port 1, go to assign excitation, select lumped port, draw the new line integration from port 1 to port 2. Successfully defined. Click finish button. So this is port 1, and rotate this structure. Select lumped port excitation of port 2. Select port 2, right click on port 2, go to assign excitation, lumped port. Select new line integration, draw the new line integration from lower port to upper port successfully defined. Click finish button. So now change the plane, coming back to XY plane. Select 50 ohm transmission line, both the ends of the 50 ohm transmission line, and rectangular sheet 3, rectangular sheet 4, rectangular sheet 5 and ground plane. Right click that position, go to assign boundary, select perfect E boundary. And this is perfect E boundary. And now assign analysis setup, go to the simulation, select advanced. Now where the operating frequency is 2 GHz, I am selecting maximum number of passes are 12, maximum delta S is 0.02, click OK button, and selecting the sweep type is fast. Minimum frequency, starting frequency is 1 GHz, ending frequency is 3 GHz, points are 101, click OK button. Now assign open region radiation boundary, go to the model, right click on the model, create open region, click OK button. So this is open region radiation boundary. Check the validation of the design. The design is successfully validated, and now start the simulation. Click analyze all button. So now here red color curve is S parameter return loss, and green color curve is the insertion loss curve, that is the band pass filter response curve.